Hello all. This is our final year project and I am from the Department of Electronics and Communication Engineering studying in Veltech Multitech Dr. Rangarajan, Dr. Sakuntala Engineering College, and the title of our project is that a wireless sensor network attack prediction using artificial intelligence, presented by Pooja, Lavanya and Jivika. We are guided by Dr. V. Prabhu sir. So these are the contents of our project. So this is the objectives. The main objective of our project is to predict the attacks in wireless sensor network while transferring the data in the transmitter path. Here we used machine learning technique for analyzing the data from the data set. So basically the machine learning technique contains two types: supervised machine learning technique and unsupervised machine learning technique. Here we used a supervised machine learning technique to train the algorithm that to classify the data and to get predict the outcome accurately. So, the introduction. This wireless sensor network has attracted significant attention in the research and development due to its tremendous application in the medical, commercial communication sectors to enable to interact with each other controlled remotely. The analysis of data by supervised machine learning technique to capture several informations like variable identification, univariate, bivariate and multivariate analysis and missing value treatments. The wireless sensor network has wide applications like environmental monitoring and tracking of target nodes for communication. This is the existing system in a wireless sensor network based fluid pipeline leak monitoring system. This system has numerous number of sensors that are deployed along the pipeline network. Here the great number of measurements are continuously transmitted from the sensor node to the corresponding sink node. In this existing system, an enhanced leak detection and isolation (NLDI) method is used, in which the several important parameters such as friction factor, pressure wave propagation, speed can be updated, resulting in the improvement of leak localization accuracy. So these are the drawbacks of existing system. The existing system does not focus on classifying the wireless sensor network attack types, and this system did not get the proper accuracy, and there is no deployment part in this existing system, and machine learning technique is only used for analyzing purpose. So this is a proposed system. The proposed model is to build a machine learning model for predicting WSN attacks. Previously they find the accurate leak detection and isolation result only. This wireless sensor network attack detection is an important technique for recognizing fraud activities, suspicious activities, network intrusions, and other abnormal events. Each and every column feature are analyzed, then the pre-processing and visualization of data are done. The model is built based on the previous data set where the algorithm learns data and get trained. Different algorithms are used for better comparisons. The performance metrics are also calculated and compared. The advantage of the proposed system is that the machine learning algorithm is implemented for classification purpose here, and more than two machine learning algorithms are used for the comparison to getting the best accuracy, and mainly deployment part is done here for getting the result accurately. So these are the list of modules: data pre-processing, data analysis of visualization, and implementation algorithm 1, 2, 3 and 4. They are Navy bias, AdaptBoost, K nearest neighbor and voting classifier. Finally the deployment part. This is the block diagram of our project. Here we download the data from the Kaggle website and send to the pre-processing. The pre-processing part in which is used to find the missing values, duplicate values and what type of data. Then the visualization shows the data in the pie chart, bar graph, etc. for the understanding purpose. And the algorithm implementation part. Here we use four types of algorithm to compare the accuracy. They are Navy bias algorithm, AdaptBoost algorithm, K nearest neighbor algorithm and voting classifier. After getting the accuracy of each implementation of algorithm, we compared the accuracy and the best is sent to the deployment part. Here what is data pre-processing? The validation technique in machine learning which are used to get the error rate of machine learning model, which can be considered as close to the true error of rate of data set. This the pre-processing is mainly used to find the missing values, duplicate values, and description of data type, whether it is float, variable, or integer. The sample of data used to provide an unbiased evaluation of model fit on the training data set while tuning model hyperparameters. Then here it is the data visualization. The data visualization is an important skill in applied statistics and machine learning, which provides an important suite of tools for gaining the qualitative understanding. This data visualization can be helpful to know a data set and can help with identifying the patterns, corrupt data, outliers, and much more. This can be used to express and demonstrate key relationship in the plots and charts that are more visceral. So these are the accuracy of algorithm that we implemented. Firstly, we get accuracy of Gaussian Navy Bayes algorithm, which gives 65.78459910029109 as a accuracy. So this is the accuracy of AdaBoost classifier, and it gives 76.96480 as a accuracy. And this is the accuracy of K nearest neighbor, which gives 93.311, and this is the accuracy of voting classifier, which gives 94.48266. So we compared all these implemented algorithm, and we get the best accuracy of the algorithms. So this is a graph through which we can understand the accuracies of algorithm, and this is the table. So this is the final module of the project, and in this module the trained machine learning model is converted into the pickle data format file, that is .pkl file, which is then deployed in any framework for providing better user interface and predicting the output of how much the given data is predicting. The WSN attack. This is the module diagram of the deployment part. Import packages, read PKL file, input data, and getting prediction. The import packages will be appear in the code page that we used, and it will read the whole PKL file, and the data is given as an input to get the prediction. So this is the sample output of our project. We given input data here, and we get a result as a gray hole, which means that what type of attack that is predicted here. These are the environmental requirement of our project. Contains both software requirement and hardware requirement. Software requirements: operating system Windows 10, tool Anaconda with Jupyter Notebook. And hardware requirement: processor Intel i3, hard disk minimum 10 GB, RAM minimum 4 GB. The conclusion of the project is that analytical process start from data cleaning and processing, missing value, exploratory analysis, and finally model building and evaluation. The best accuracy on public test set of higher accuracy score algorithm will be find out. The founded one is used in the application, which can help to find the wireless sensor network attack prediction. The future work of our project: wireless sensor network to connect with live sensor IoT AI model to automate this process by show the prediction result in web application or desktop application, to optimize the work to implement in artificial intelligence environment. So these are the literature survey. And these are the reference of our project. Here we use Anaconda Navigator tool, in which we can use both Jupyter Notebook and VS Code. So now we are going to use VS Code here. Now select the file option and open the folder. The code that we created was already saved in the document path. open the code. Now the code that we created will be opened like this. Now we are going to debug it. We should always keep in base while we debug it. So click the command prompt option here. It will become a base. Now type Python manage.py run server. It will create a link of the output page. The user page will be opened, and this is the output page. Here we should input the data that we collected from the Kaggle. After entering the data that we collected from the Kaggle, we should give submit. We'll get the output as gray hole. So the type of attack is predicted. This is our project. Thank you.